We're going to do two examples in this video. The first one, prove that the difference between the squares of any two consecutive integers is equal to the sum of those integers. So we want the difference, that's taking away the squares of two consecutive integers. So let's do that first, and then we'll worry about that being equal to the sum in a minute. So let's get our two consecutive integers to begin with. So if I start with my first integer, I'll call it n. There's no restrictions here about it being even or odd or anything like that, so I can just do a nice simple n. Then the consecutive one, the one after that, will be n plus 1. And I want the squares of those integers. So square n, I get n squared. Square n plus 1, I get n plus 1 squared. And I wanted the difference between these. So because it was the difference, I'm going to do the bigger one, take away the smaller one. And now if I expand this bracket out here, you could expand it like that and go n times n is n squared, n times 1 is n, 1 times n is n, 1 times 1 is n. So that you get n squared plus 2n plus 1. Or hopefully you know the shortcut here where we can just go square this to get n squared. N times 1 is n, then double it, 2n, and then 1 squared is 1. So we've expanded those brackets. We've got the minus n squared over here as well. Now you can see that we can collect up these like terms, they cancel out, and so we just get left with 2n plus 1. So this is the difference between the squares of our consecutive integers. Remember, I need to show that this is equal to the sum of those integers. So let's consider that part now, the sum of those consecutive integers. Remember, the integers were n and n plus 1. So the sum of those is n plus n is 2n. And now we can just write our conclusion. The difference of the squares and the sum are both 2n plus 1. They're both equal. So there we go. I have proved it. Second example. Prove that the sum of the squares of any three consecutive even numbers is always 8 more than a multiple of 12. So this 8 more than a multiple of 12, that's a bit awkward, but we'll worry about that in a minute. Let's focus first of all on the consecutive even numbers, squaring them, and then adding them together. So let's write down our three consecutive even numbers. The first one will be 2n. The second one can be 2n plus 2, and then the third one will be 2n plus 4. We're going to square each of them, and then we're going to add them together. Right, expanding each of these out, 2n times 2n is 4n squared. And then here, just using our shortcut, 2n times 2n is 4n squared. 2n times 2 is 4n, and then double it. 2 squared is 4. 2n times 2n is 4n squared. 2n times 4 is 8n, and then double it. 4 times 4 is 16. So we've expanded out those squares. We are now going to collect up the like terms here. So I've got 4n squared plus 4n squared plus 4n squared is 12n squared. I've got 8n plus 16n is 24n. And then I've got the 4 plus the 16 is 20. So this expression is the sum of the squares of three consecutive even numbers. Now let's get back to that complicated part. I need to show that this is always 8 more than a multiple of 12. So let me think about what that 8 more than a multiple of 12, what would that actually look like? 8 more than a multiple of 12. Now I know that a multiple of 12 is timesing by 12. And 8 more than that would mean to add 8 onto that. So that's making me think, I somehow want to show that this is the same thing as 12 times something, a multiple of 12, plus 8. This here represents 8 more than a multiple of 12. So I want to try and write this in this form. So I want to have a plus 8 on the end. I don't want that to be plus 20, I want it to have a plus 8 on the end for the 8 more. Because of that, I'm going to write this. Instead of writing 20, I'm going to write 12 plus 8. Obviously, we know 20 is the same thing as 12 plus 8, but by writing it like that, it matches up with this. I've got a plus 8, I've got 8 more than. Now all I need to do is hopefully show that this is a multiple of 12, which I can do easily. 12 goes into each of these. So if I factorise 12 outside here, this is a multiple of 12. This is 8 more than a multiple of 12. And there we go. I have shown that the sum of the squares of 3 consecutive even numbers is 8 more than a multiple of 12.